My name is Dorka Volokova, and I'll be helping with moderating today. So this first episode is going to focus on quality engineering. We will have a look at the Strimzi project, and we'll talk about how systems like Kafka and Kubernetes are tested at Red Hat. Let me introduce you to our speakers today, my awesome colleagues, the maintainer of the Strimzi project Jakub Stejskal, and the Strimzi system test contributor, Maros Orszag. So they'll start with the short introduction of what their team actually does at Red Hat. Then they prepared 2 live demos for you. So this session is being recorded. You can have a look at the demos again after we finish. And then at the end, there's time for discussion. However, we encourage you to ask your questions immediately in our Q&A tab. I think it's on the right bottom corner called Q&A. And one of the speakers is always going to look there and reply to your questions. You can also ask to elaborate on certain topics, and we'll make the changes. Anyway, I think that's it for the introduction, and we can welcome our 2 speakers, Jakub and Maros, on the stage. Jakub.
Okay, hello everyone. I kind of wanted to introduce myself, but Dorka already introduced me and Maros, so I think we can proceed to the content of the presentation, and yeah, we can start. Hope you will enjoy it. So over to Maros.
Thank you, Jakub. So please, next slide. So today, as Dorota said, we will learn something about the Kafka. We will know something about the Kubernetes environment, and moreover, we will introduce the Strimzi project. Then Jakub will have the demo, which will be specifically for the Telegram and the usage of the Strimzi. This presentation, we will concentrate it on our work, how the QE works with the automation. And moreover, last demo was designed for the use case which can customer have, for instance. And finally, we will have the summary. So that's about it. Next, please. So what is actually Kafka? You can define this word many ways, and you can see these buzzwords like distributed, horizontally scalable, PubSub-oriented, or high availability by default. So I will put this very simply. When you imagine some distributed system, you probably see some multiple nodes which are sharing some resources, and that's basically it. The system will have some redundant data, but it will be really fault tolerant, and your data will be stored and protected. On the other hand, the horizontally scalable means that your cluster can be scaled, and you can instance your nodes of, for instance, in that case, Kafka, or I don't know, like maybe 10, maybe 20 nodes to make your cluster very fault tolerant. On the other hand, we have the vertical scalability, which is basically just increasing the resource for specific Kafka instance. Next, we have the PubSub-oriented, let's say, pattern, which basically means that every messaging system has some clients, and in this case, the pub means publisher, and in Kafka is the producer, and on the other hand, we have the sub, which is subscriber, and on the end as consumer. The last point is high availability by default, and it just means that if the one of the nodes of the Kafka fails, it doesn't even influence the performance of the cluster. We have the use cases of the Kafka, for instance, Uber, Netflix use it, Spotify and LinkedIn. And for instance, in Netflix, they use it for recommendation system which basically real time. It is really good to say real time when you just watch some films. It's just basically from that your input data will create some classification, and when you next came to the Netflix, it will just give you some preference films and movies, etc. Next slide, please. The second technology which we need to learn is the Kubernetes. And again, I will put it in the simple way, and maybe we will move to the past a little bit. So we firstly have the concept of the bare metals, where we have just EC, thing was fine. But maybe some of us or some of you noticed a problem, which can be like price. For instance, when you want to scale your application, it's really hard because, and the price is the majority of this, because when you want to scale your application, you will have to buy another PC. So it's not great. And as well as management of servers, it's really like not so easy to manipulate with these PCs. Next concept was the virtual machine, which removed this disadvantage of price because and also the scalability, because we were able to just tailor application and isolate the environment from that. But still, there was a problem with the operation system, and you know that the operation systems consume very, very memory. On the other hand, we had the pure containers, which just removed this operation systems. And for instance, you probably know the Docker and so on. It's hard to manage the server, manage of your application, because basically you create instances, and if you want to know or you troubleshooting, it's really hard to create, check the ID of the Docker instance, go to the concrete instance and stuff. The answers on this was the manager of containers or the OpenShift. You may be asking, what is the difference between these two? And the answer is very simple. For instance, OpenShift provides certificates, includes very much plugins, and also OpenShift has very great UI. When you just want to deploy your application, you just click some buttons and everything will be ready to use. So next slide, please. And lastly, this is the Strimzi. And what we learned was the Kafka and Kubernetes. And basically what this Strimzi is just encapsulation Kafka inside Kubernetes environment. That's how simple is that. Moreover, Strimzi is a CNCF sandbox project, which just basically means that it is part of the great organizations, and the CNCF is a part of the non-profit Linux Foundation. Also, if you are familiar with the Kubernetes, you also know the Kubernetes operator pattern, which is basically when you have some system and you put it into Kubernetes, you should create some definitions how to deploy it very quickly, how to add it, how to update, how to delete it. And this is what actually cluster or maybe operator will provide you. It is some API, which is basically these methods, like I mentioned before. As you can see from this picture, we in the Strimzi we have the operators like cluster operator, which just basically deploys and manage clusters, Kafka clusters in that case. We have also the entity operator, which just encapsulates the user operator and the topic operator. And I think the naming is self-explanatory. So user operator just deploys and manage users, and same with the topic operator. Also, as I mentioned, the Strimzi, it's simply configurable. So it's basically just typing some APIs commands via OpenShift Kubernetes client, and you will do what you want. Just simple. And the last point is the Kube native experience, which basically means that the systems were originally created by and run into operation systems like bare metal. And after time, these systems was put to the Kubernetes environment. And that basically means that Kube native, and also, as I mentioned, with specific API, which will like your work, it will be really easy to use it. And maybe basically that's all what I want to say, and I will give you now Jakub. And Jakub will show you a demo about the Telegram and use case with the Strimzi. So Jakub, stage is yours.
Okay, thank you. Okay, can you see my screen?
Yes.
Yes, you can.
Okay, thank you. So I prepared a very short demo where I will show you how it's simple to deploy Kafka into Kubernetes cluster via Strimzi. I also prepared a scenario where I will use Telegram application. You already know that. And I will basically use Kafka Connect in my cluster. And together with KML Kafka connector, I will send messages from Telegram to Kafka and from Kafka to Telegram back as a response. One more note, all the code which I will use is available on GitHub, and there will be a link at the end of the presentation, so you can try it by your own. And maybe one more thing, when I set up everything, you are able to chat with Telegram bot, which I prepared for this demo as well. Okay, let's start it. At first, we need to create a namespace. We can call it, for example, demo. And let's switch to this namespace. Now we need to apply Telegram credentials. The Telegram credentials are not part of the code. It will not be available on GitHub, but there are steps which you need to apply to achieve the same behavior as I'm doing right now. So don't worry. Okay, now let's apply Strimzi, or not apply, install it. And can watch the progress by command watch get pod. It will show us the pod in specific namespace, and now we can see that Strimzi cluster operator is running, and it will be ready in a few seconds. Meanwhile, we can apply the configuration for Kafka. It will take some time until Kafka will be up and ready. So meanwhile, I will show you the configuration itself. Kafka configuration is a very simple YAML file. We use their Kubernetes extension for CRDs. So this Kafka resource is basically part of Strimzi project. You can see there are some basic configuration like replicas of the Kafka brokers, which means that how many brokers will be up in the cluster. Some configuration for resources means that, how much memory will each pod consume. Configuration for listeners, which is Kafka specific. And for example, there you can see the metrics part which Maroš will show you more deeply in his demo. Another part of the configuration is for Zookeeper, which is very similar. There are a number of replicas, some resources requests, and again, metrics configuration. There's also specification for entity operator, which contains topic and user operators, and Kafka exporter, which is for exporting the metrics. Okay, we can see that Kafka is creating, so hopefully it will be up in a minute. Meanwhile, I can show you also configuration for Kafka Connect. I prepared a YAML file which contains topic for sync and source connector, which I will use, and user, Kafka user, and configuration of Kafka Connect is down there. It contains some metadata like name and annotation for our connector operator. I also had to build a specific image which contains camel connector. So this image is available on public Docker Hub, so you should be able to use it, or you can build your own. It's up to you. And yeah, there are some other configuration we had with for Kafka and Zookeeper, for example, metrics, replicas, and so on. Okay, Kafka is almost up, so let's wait a couple of seconds, and after that we should be able to apply Kafka Connect and wait a little bit for Connect. Okay, can do it now. I hope. Well, let's wait a couple of seconds until entity operator will be up as well. It will handle the Kafka user and topics, so we want to avoid any problems. Okay, let's apply it now. It will take around 1 minute. So meanwhile, I can show you configuration for Telegram connector, source and sync. It's a very short configuration. I just specify there a class which I will use. It's part of Camel, and configuration for connector itself. The most important part there is topics, which I will use. I will use Telegram topic source, and another important part is the token, which I need to access the bot itself. Basically, the configuration for sync is the same. Only difference is in topic and in class configuration, where I use sync instead of source. Basically, the source connector just grab the messages from Telegram and send it to Kafka, and sync connector will consume messages from Kafka and send them back to Telegram, so we will be able to see the response. As part of this demo, I also prepared a very simple application which is using Kafka streams. Basically, this application just consume messages from a source topic, and based on the data there, it generates response and send the response to sync topic. Okay, so now we can create connectors and deploy the application which I prepared. Okay, we can see that the application is up and running. We can also attach consumer to the Telegram topic source, and we should be able to see the messages which will be sent to the topic. And now we can start the chat with bot. We can send some message, and we should be able to see the responses. Okay, don't expect any AI there. It's just a very simple application just for this demo. And here we can see the messages which I sent to Telegram and are processed by my application and sent back from Strimzi bot. I will keep this application up until the presentation is finished. So if you want, you can install Telegram and find Strimzi QA bot and send some messages there. Okay, that's all from my side. So let's get back to Maroš.
Thank you, Jakub. So now we will proceed with the second part of the presentation, which aims to the QE work. And firstly, we will talk about, we are bordering writing this, right? And you can imagine the work like the team is like consists of some developers, some QEs, and etc. And the developers will provide you some code, which has to be tested somehow, right? So you will write some end-to-end scenarios for that, and based on these scenarios, you will write exact some tests in your specific or favorite framework. We're using the JUnit 5 for whole automation with a bunch of things, and you can imagine that we need somehow to abstract the way how we communicate with the Kubernetes. And for this communication, we use the Fabricate client, which I will show you in my demo in a way. And also our suite, for instance, has many auxiliary methods, which just do some listing, as I mentioned before, deleting, updating, etc. And we have also the representation of resources. For instance, Kafka, we have a resource for Kafka, but this whole things I will show you in my demo. So Jakub, I will give you a voice. So let's proceed to the next slide.
Okay, so yeah, basically the QE work in Strimzi and in Redhead itself is not just writing the test. So there's plenty of another tasks which you need to do. And a very good example is another part of automation. And now I will try to describe you how we use CI/CD with Strimzi project and how GitHub integration. We use free CI/CD tools. At first, we use Travis and Azure pipelines. We use those technologies to run unit tests, build the whole project, and run specific end-to-end scenarios if needed. Also, those jobs build the images which are pushed to Docker Hub, and we can use them on our local environment or any Kubernetes cluster without need to build them on a local computer, for example. Travis and Azure jobs are triggered automatically with each commit, which is great. So in case we will push anything to master, we can be sure that new images will be updated in Docker Hub and users can use them. This approach is used for releases as well. It's just with different tag than master, of course. The Jenkins is in a different part of testing there. We use Jenkins for mostly for the nightly builds, but we use Jenkins also for PR builds, as we say. We basically set up a simple job which monitors all PRs which we have in Strimzi, and based on the comment which any of the admins leave there, the Jenkins will trigger the job with test, and based on configuration which you pass to it, It will run the tests, build the images, and so on. We use Jenkins basically for some long-running scenarios because Travis and Azure has some limitations for us. So that's the reason why we use Jenkins and Red Hat Infra for that. Regarding nightly testing, every night we spin up several Kubernetes clusters and we run our end-to-end scenarios against them to see that Strimzi is working, it's stable, and we kinda can be sure that anything wasn't broken the day before. In case there are some failures, and I can say that there's always some failure, unfortunately. We use a tool called Report Portal for failures analysis. Basically, every nightly job. Currently, we have 8 nightly jobs because the test takes around 30 hours. Sends the results to the report portal, and every day, let's say every morning, we are able to see the results there, and the report portal do the analysis instead of us. So we can see if test failed because it's flaky, it failed because some environment issues, or it's a problem in Strimzi itself. It saves us a lot of time. Very, very useful tool. Okay, next slide, please. So until now, we basically speak about testing itself, but we didn't mention an integration which we use within Strimzi project. I can mention there the project which we use or the tools which we use in it. We directly integrate Kafka Connect. I show it in my demo. And we also integrate, for example, Mirror Maker, Kafka Bridge, and Cruise Control. So from QE point of view, we should be able to work with those components. We should know how it works, and we should be, of course, able to test it. It means that we need to know how we can deploy it, how Strimzi deals with it, and so on. We integrate those components directly, but we also use several components or projects, not just as a dependency, but we basically set up it independently on Kafka cluster, and Kafka cluster has some connection to it and takes information from it. The example of those integration are, for example, Keycloak and Open Policy Agent. We use it as authorization servers. It means that in case you want to test the option that Kafka can be set up with some OAuth configuration, we need to have some authorization server for it with some configuration as well. And we need to know how to deploy those applications, how it works, and how we can set up and change the configuration of it. So not just we need to know the Strimzi itself, but we need to know how other components work as well, which is somehow sometimes it's pretty challenging, but it's exciting as well. Another project which we use are, for example, Jaeger for tracing and Prometheus and Grafana for metrics collection and visualization. And I think Maroš will show you more about Prometheus and Grafana in his demo. Okay, last thing of the slide is about our workflow. Basically, how it works in our QE or in Strimzi team is that we usually build the project and run unit tests and integration tests. It's done within Azure Pipelines and Travis. Within those jobs, also we build the images. And after that, in a separate jobs or builds, we run end-to-end scenarios and evaluate results with the help of the report portal. About end-to-end scenarios, Maroš will talk you more, and he will also show you a demo with his end-to-end scenario, which he implemented for his bachelor thesis. So that's all from me, and let's get back to Maroš.
Thank you, Jakub. So let's proceed with the next slide. Yes, and here you can see, you may be probably asking a question, where is the real scenario which can be used? And this is the one I will show you in a few minutes. But before that, we can maybe describe these components which you see in this diagram. So the first one is the load generator, and the second one is exposure. They have similar properties, like they are written in the Quarkus, which is subatomic and supersonic Java. If you know probably some annotated driven framework like Spring, it is basically isomorphic thing. So the load generator and his responsibilities will be to load some data, which will go to the Strimzi. The Strimzi will store this data somehow. Then the exposer will just grab this data and somehow classify it, aggregate it, etc. After that is completed, the exposer will, the name is self-explanatory, it will expose this data, aggregated data, of course, to some endpoint. This endpoint will be now consumed by frontend, which is basically single web page application, which just grabs this endpoint and show this data to the user. You will see that. And yeah, I can now show you the screen. So yeah, so Gabby, you can stop the screen and I can, yeah. It seems that I cannot screen share. You cannot see my screen, right?
Nope, not yet.
No.
Okay.
Looking good. We see the black screen. But nothing on it.
Can share screen. I don't know what's happened, so most likely you'll see now.
I think we see the screen. We see the BlueJeans interface.
Okay. Okay, thank you. So now everything is fine.
Yay.
So let's proceed.
Yes, it's there. Awesome.
So before I run the whole test case, maybe I can run and then I can meanwhile somehow tell you what is going on.
Maroš, maybe a little note. Can you make it bigger?
Yes, of course. So we will have this example, but with like advanced techniques, like for instance, Grafana and Prometheus. But let's start with the basics one. Here, we will just automatically set up the cluster set up the namespace, apply, as Jakub mentioned, apply some cluster operator YAMLs, which defines the whole operators. You can see from the console that is already something happening. And I can show you maybe the pods. After that is completed, I will apply the Kafka metrics, which just needs to be done before I will use these metrics for the Prometheus, and Prometheus will expose these metrics to the Grafana, which will show you some statistics, etc. So now we can see that I wait for the pod creation. And why is that? Because in the Kubernetes, when you deploy some application, it must be set up. And if you don't do it, you will probably cause some race conditions, which can easily happen. So that's why we waiting. We have some dynamic waits for that. Okay, now we can see that our Kafka cluster is set upping, so we can proceed. Here I will deploy the Prometheus, which basically is bunch of the YAMLs, as you can see, with the alert manager, etc. And it just defines your application, how it's got. So yeah, let's see. Here is the deployment of the Grafana. It's very simple. It's just one YAML, as you can see. And we will proceed to the case which I have prepared for you. Here, as you can see, I have some deployment of the load generator, and maybe I can show you what this is for. Here it is. As I mentioned before, we're using the Fabricate client, right? And by Fabricate, you can also somehow create your own instance. You can see that, for instance, a load generator, maybe I can show you some of. Oh, yes, yeah. And here, for instance, you can see load generator deployment. Has, for instance, some name, has also the image, which I specify, and it runs this command, which just running the jar. This is basically the same, and this is a morphism. And also I add these two environment variables, which just basically means that I'm putting some generation interval. In that case, it will be really slow. So maybe we can proceed to this verification code here. Yeah. So I will deploy the load generator, exposer, and also the React, which is just the front end of the application. Here you can see that the load generator is just creating. Also the exposer, etc. And now we will have to set up our Grafana. And for that, I will need to port forward to that. So let me see this line, which basically means that the Grafana is now is no exposed. And with the port forwarding, I will be able to access it from my local host on the specific endpoint. So this is the Grafana. For those who really don't know what this actually is, it's just basically gives you opportunity to analyze your data flow, your statistic about your application, etc. But before that, we need to set up our Prometheus, because the Prometheus are exporting some valuable metrics. Prometheus is basically by default running on this port. We will save and test and configure, and we see that Delta is updated and source is working, which is nice. Now we will need to somehow build our dashboard, and we need to import via this thing, and the dashboard is usually represented by JSON. For that, I have this JSON, which basically you can see that there are some annotations, some panels, etc., but I'm not going to the detail. We need to paste this. We will load it, and now you can see that it will be named Strimzi Kafka, and I need to specify the Prometheus, which is the metrics which we need. Okay, and from this point, you can see, for instance, how many brokers we have in the cluster. For instance, in that case, we are using just 3 brokers. We are using 150, etc., replicas. We have tons of these statistics which can analyze your system. For instance, if your system will be out of memory, or maybe you will have 80% of usage in memory, you can predict that your system will crash soon, and you should buy some RAM or whatever. You probably catch the point. And also, maybe I can show you the applications, which is still running on this port. And here's the front end. And to put it very simply, you can see the Google's map, to be specific, some location where we have each ballot just represents the sensor, which holds the information about the concentration of gases. And by that, you can analyze that some of these countries are polluted, etc. And it's not good. Basically, that's the whole idea with all the metrics, as you can see. For this use case, I just didn't even get into more incoming message rate. As you can see, it's really low, but you can still increase this speed and get some results like when you can see in the production. So this is everything from me, and I will give you over to Jakub.
Okay, thanks. So next slide, please. Okay, so let's go through summary of this presentation. Basically, we learned that we need to write boring tests, but we also need to do a lot of other important and exciting stuff, like integration with other products, learn CI/CD stuff, and learn a lot of another projects which we can use. We can also use a lot of new technologies which are available every day on Kubernetes. So one of the pros as well. Another thing, as I mentioned, we use a lot of cool technologies inside the project itself, and because we are upstream, we are open to any improvements and any new things which are useful for us, which is great. And one of the latest part is that we had a great community around projects like Strimzi. In case you want to learn anything new, there is a lot of people which can help you, let's say, with set up the environment or with basic steps with Strimzi itself or projects like this. Or if you want to start contributing, there is a lot of people which can help start you with that and answer any questions which you have around project. In case you will have any questions or you will be interested more about Strimzi, you can visit our GitHub or our web. You can see the links on the slide. We also have a Twitter, so you can find there some useful information about blog posts, about new releases, and so on. Basically, we have blog as well. It's part of our website, and one of the latest blog posts is about our end-to-end scenario and testing, so you can check it, and hopefully we'll find some useful information there as well. And we also have a Slack channel hosted by CNCF. Okay, there is also a link to my demo. In case you have any questions, you can open issue or ping me on Slack, or just send email. It's up to you. And also, I want to mention the talk of my colleague Jakub Scholz. He will have talk tomorrow on Brno Java Meetup, and he will talk about operators and stateful applications on Kubernetes. And he will do some pretty nice demo with Strimzi as well. So if you are more interested in Kubernetes and operators, I definitely recommend his talk for you. And that's all from me and from Maros. Thank you for your attendance.
Thank you, Jakub and Maros, for the awesome webinar. So this is the time for discussion. So if you have any questions, just ask them in the Q&A. And in the meantime, I can maybe start with the question about your Redhead journey. So how did you start working here? I kind of know that it has something to do with you still being students, and I know we have at least 9 students present, so that will be definitely valuable for them, as well as maybe a question on top is why Red Hat and why open source?
Okay, I think I can start. So I started in Red Hat 3 years ago. I started as an intern. Basically, I just visited the open house event in Brno, and I wanted to do my master's in Red Hat. And one team, it's messaging now, it's IMQ. They wanted me, so I joined the team. I played with performance. We used a great tool called Maestro, and I write my master thesis in 1 year there, which was great. And yeah, when I finished my my university, I got an offer, and I accepted and moved to Strimzi project and Strimzi team. And yeah, basically that's the whole story. I really like the work with folks in Strimzi. We have a great community around it and great team. And my other colleagues, which kind of in the office, are great people. We can share the knowledge in case someone needs some help. We can very quickly solve the issues, and yeah, we are, let's say, kind of a family here. So yeah, that's from my point of view.
Okay, and from my point of view, I have been in Red Hat for maybe more than 1 year, and before that I was in many interviews. But when I have an interview in a Red Hat, to like put it in a simple way, it was like really great experience because I feel like I am in family, as Jakub said, and it was really great moment for me because everybody is really serious and etc. But in Red Hat, I feel like I already know them. So of course, as we have the opportunities to play with really enormous and great technologies such as we said, Kafka or Jaeger tracing and all our stuff, etc. It was great opportunity to learn something more, and even better was to wrote the bachelor thesis, which you saw. And yeah, why Red Hat? I described it like. All right. I think that's all from my point of view. Why I joined the Red Hat.
Thank you very much. I don't see any questions in the Q&A tab, so I think we can finish. If there's anyone who wants to ask, now is your last chance. In the meantime, I'd like to invite you for the next episode. That will probably happen in a month. On October 29th, we are going to talk about OpenShift. We will introduce yet another theme, and we will prepare again live demo for you. And if you want to know exactly when it is going to happen, definitely follow us on social media. So that is Red Hat Czech on Facebook and on Twitter and LinkedIn. And you can also subscribe to the group on Meetup. Thank you, everyone, for attending, and hope to see you in a month.